Okay, so the question is about, on the assignment, I make this comment about exhaustively testing your class before you move on to the next class. Uh-oh, no sound. Oh. Why does it keep? Yeah, I think I'm getting sound here, right? Hello? It's echoing. Huh. All right, so one day I'm going to teach a class again without all of this technology, and it's going to be a lot more enjoyable. So mostly I used a bit of hyperbole there because I didn't want you to just ignore my statement. So and basically it's up to you, right? I mean, you're the one that's going to have to deal with it if it turns out that you didn't test it exhaustively enough and there's a bug in it. So I don't think you need to worry about the data file that I provided. Or wait, is there? Yeah. In fact, I'm not sure if you could.
Well, because isn't the insertion, the insertion uses a string.
Yeah.
So I think that string is either going to be a file stream or
CN.
Okay, so CN.
Okay. So I guess for me, if I was testing it, okay, so what am I supposed to say to that? No, I don't know. All right, so I'm trying to conduct class and also have this conversation at the same time. So I guess if I was doing it, I would just write myself a little client program, and I'd probably have a little loop that just read in a measure or an ingredient, whichever one it is, and I would just type some stuff in and see if it handled it correctly. And I guess, would that test the star equals 2? I guess you might have to do something a little bit different on that, but you could work that into your client program somehow. But I'm thinking of a client program that's maybe 10 or 12 lines, I guess. I don't know. I haven't done it, so I could be wrong. It could be 20, but does that answer your question?
Yeah.
Okay. Yeah.
When you send out an email on Monday regarding people having trouble to email you, should we be emailing to the Santa Rosa one, or is there an email account?
Santa Rosa one.
Okay, yeah.
Yeah.
I mean, you said emails. I wasn't sure
Right.
if you were receiving them.
Okay. Yeah, that's a good question. How come I'm not responding to your emails? Yeah. I don't have to. I won't go into detail, but I can tell you that I didn't have a chance to answer very many emails yesterday, and I have 119 now. But hopefully, I'll be able to get to those today. So, and certainly that's not a good thing, and I apologize for that. And if that causes you to need more time on something, just let me know. Does that make sense? Okay. Anything else?
Okay.
Okay. All right. So how's it going with like you're working on an assignment that has to do with dynamic arrays, but in lecture we're doing something completely different. I hope that's okay. I mean, it kind of has to work that way, right? Because I cover something and then you do the project on it while I'm covering the next thing. So what I want to do today, my plan is I'm going to finish up the delete function here, and then I kind of want to take a step back a little bit and go through some of the stuff that I've been glossing over as we've done these examples in class. You know, things like namespaces and what else? Just a couple other things like that. Macro guards, type defs, things like that. So there's some stuff that he talks about in the text, and he says, okay, you should always do this in your classes. And I haven't gotten to that point yet where I'm including that stuff. So that's sort of my game plan. We'll see if we get that far. All right, so here's delete. And did I have a picture with this? Oh, the picture's probably gone now, huh? Don't mind me, I'm just playing. Ah. Okay, good enough. What am I missing over there? Colors. There we go. All right, so what we have here is a delete function that will work in the general case, I think. So if I'm deleting a node from the middle of a linked list, I think that'll work. So and do I have a client program that includes that delete stuff? Yeah, except I need to call it del instead of delete. Okay, so I think we could test this. Oh, my captioner left. So let's insert a bunch of numbers, 5, 9, 7, 16, 12, 4, that's enough. Okay. Now let's skip this part, -1. Now I want to delete something. I'm not sure if I haven't thought about whether my code's going to work if it's the first item or the last item in the list. But it should work if it's something in the middle. So if I say 16, the list is now 4, 12, 7, 9, 5. Right? I can maybe just do one more. I'll do the 7. Okay, 4, 12, 9, 5. Now, let's see what happens if I try to delete the 4. I think that might be okay. At the end of the list, that should be okay, actually. Oop, apparently not. Okay. Okay, so we got some work to do, right? But I think we've got it done in the general case. We just have to look at some of the boundary cases now. Did it get bigger again? Okay, so let's, I think I'm going to actually need to have a little linked list here. So let's just do 3. And, yeah. Okay, so there's my linked list. And let's look at what's going to happen here if I'm trying to delete the last item in the list. Okay, so just remembered that I forgot my notes. I guess I'll have to wing it here. Oh, that's the one. Delete. Okay, so I have a cur pointer and a prev pointer, and they both start off pointing at the first item. So let's see, prev pointer, cur pointer. And they start off both pointing at the first item. And now I'm going to say, while cur pointer is not null and cur pointer arrow data is not equal to num. Okay, so that condition is true. So I'm going to say prev pointer gets cur pointer. It already is. And cur pointer gets cur pointer arrow next. So after the first time through the loop, I'm going to have this, right? I'm not going to put the arrowheads on. You get the point, right? Okay, and then we go back up. Cur pointer is still not equal to null. Cur pointer arrow data is still not the thing we want to delete. So I'm going to set prev pointer equal to cur pointer. I wonder if there's a way I could edit that. Okay, so prev pointer gets cur pointer, does this, and cur pointer gets cur pointer arrow next. There's this, right? Okay. Now I'm back at the while loop condition again. Cur pointer is not equal to null. Cur pointer arrow data is the number I want to delete, right? So the while loop condition is now false. Okay. So I'm going to come down here. If cur pointer is not equal to null, found gets true. Prev pointer arrow next gets cur pointer arrow next. Prev pointer arrow next. What's cur pointer arrow next right now? Null. So I'm saying prev pointer arrow next gets null. So that's the right thing to do, right? That's saying, okay, instead of this, I just have this, right? And then delete cur pointer. That actually looks okay to me. What did I miss? Oh, go ahead.
Are you doing something in your client program to content? Are you returning the value? Or?
No, you know what? I think I have a thought about this. So first of all, let me just before we start talking too much more, does everyone make sense that apparently, as far as we've traced through this code, it seems to us that this should work to delete the last item in the list. I'm wondering if what I tried to delete was did I try to delete the first item in the list or the last item in the list? Was it the last?
Isn't it listed last?
No, well, when you put them in, the last one you put in is going to be the first item on the list. But when it prints them out, it prints them out in order. So the last one that got printed out is the one that I should delete. So let me just try it again. Make sure I didn't just do something. Okay, so all right, so if I want to delete the last one, that would be the 5, right? Yeah, I think that is what I did last time.
This is the first one.
Did I?
Yeah.
Okay, so trying to delete the 5, that works. Okay, I must have been trying to delete the first one. So I did what you almost did, which is I was thinking, well, anyway. So then I could just to play some more, I could do the 7 and the 9, and all of that seems to be working okay.
The first one still won't work. It'll do that weird.
Right. If I try to delete the 4 now.
The one.
Oh, right. I missed the 1. Right.
There it is.
Okay. Let me go to my client program and put a space in there so I can actually see the list. The list is now. All right, let's look at trying to delete the first item in the list. Okay, so I start off with prev pointer. Let's just set this up the way it was. And so when I first start, they both point here. Okay? And then I say, while cur pointer is not equal to null, and cur pointer arrow data is not equal to num, well, it is equal to num, so the while loop condition is false, right? And so I come down here, cur pointer is not equal to null, so I say found gets true, prev pointer arrow next gets cur pointer arrow next, which doesn't change it. It's already, those are already equal, right? And then delete cur pointer, which is bad because I'm deleting the first item in the list which they are both pointing at, right? So basically it looks like I'm going to have a special case for that just right off the top before I even get to the while loop. So, you know, I'm trying to say, go ahead.
Okay, so looking over, it says cur pointer next, yes, cur pointer next, but cur pointer list. Because if cur pointer equals list, cur pointer equals cur pointer, and cur pointer is list, and cur pointer will stay list.
Right.
And cur pointer will be the first node. Does the list have a next? Because it's not a node, right?
No, well, list and
Isn't that the problem?
well, no, list does have a next. List arrow next exists, right? So in my picture here, list and cur pointer and prev pointer are all equivalent. They're all pointing at the first node. And so I can say any of them arrow next refers to the this bottom part of the first node. That's list arrow next. That's also cur pointer arrow next, and it's also prev pointer arrow next. Okay. So I'm tempted to wing it, but just to be safe, I'm going to take like 1 minute and run down to my office and get my notes. All right. So take a quick break.
sooner we done that, we could point these sound very bad, but did we take point away from us and not there kind of thing? I have no idea. I don't know what you think it's going to I thought you mentioned it, but you did really wrong, but I can't remember now.
I think it was just, we don't come alive. That's all. I think it also depends on how well you're doing on your assignments. If you're doing a little well, you want to doing it. If you don't have any questions, you're done, then there's no reason. It's just like don't make it happen.
Okay, so how can we make a special case for that situation we just had? Well, actually, that is true, right? If we want to be really specific, the situation was that list or curve pointer, whichever we want to say, is not null, and list arrow data is none. That make sense? So if there is a first item in the list, and the first item in the list is num, then we're going to do this. The other thing is that we're not going to need these if, in that case, well, let me finish setting this up first so I don't really confuse everybody. And then else I do the rest of the code here. Okay, that makes sense? So I've got my original general case is down here on the else part. So in the if part, I have to figure out what I'm going to do if the first node is the one I want to delete. Okay? So what am I going to do? So I just want to make this arrow here point to here instead, right? That makes sense to everybody? So list, where'd it go? List arrow next. Oh, so it's not list arrow next that I want to change, right? It's list itself that I want to change. So list gets what? List gets list arrow next. Okay, and really, except for one slight detail, one minor detail, that's it, right? We're done. Everyone okay with that? What's the detail that I forgot about? Here's my else. Yeah, I need. Go ahead.
Okay, no, we're gonna. I'm just curious why it's not allowed. Like, if you try to take something out of the middle, and then you try to take something out from the beginning, it's not allowed to use that case we just wrote.
Well, so this is only going to delete one thing. right? So I'm not, maybe I'm not understanding your question, but if it's the first thing in the list that we want to delete, it's going to do this case, and I don't need any kind of loop because I'm just deleting the first item and I'm done.
You want to delete something from the end or the middle of the list, and then you want to delete something from the front.
Well, this would get called once to delete the item in the middle of the list, and it would do that using this, and then later it would get called again to delete the first item in the list, and then it would do this. Okay. So the piece that's missing here was a delete, right? I have a memory leak at this point, so I want to how am I going to do that? Delete. Well, actually, okay, let's try that. Delete cur pointer. What do you think? Actually, I think that might be okay. That's not what I have here. Is that going to work? Right, I'm deleting what list points. Oh, yeah, okay, got it. So if I delete what list points to, list arrow next no longer makes sense. So I can't delete this thing first and then say list gets list arrow next. Does that make sense? Okay, so what am I going to have to do to fix that? Flip them. Okay, will that work? Delete curve point. Yeah, actually that would work, huh? Okay. The thing I'm thinking though is let's these two statements right here. Really, those are for when I'm trying to delete something other than the first item in the list, right? So I don't really need those if I'm deleting the first item in the list. So really, those should go in here. That makes sense to everybody? Then I don't have curve pointer, right. So here's what I'm gonna do. Let's put it up here and then I'll let you guys stare at it for a minute and see if it makes sense. How's that look? So really it's the same thing, I just separated it out into two separate cases instead of declaring curve pointer at the top. Any questions about that? I see a lot of people staring carefully at it, so I'm going to let you stare for another minute before I move on. No questions, huh? Anybody want me to trace through that code again? Okay, one more time. So what we're testing here is we're saying, let's say that the first node here is the one that needs to get deleted. So I say if list is not equal to null, that part's true, and list arrow data is the number we're looking for, that part's true. This number right here is the one we're looking for. So what I'm going to do is create a temporary pointer called list. By the way, none of this stuff out here is here, right? I haven't done that yet. and this isn't here. Okay, so here's my picture. So here's what I'm going to do. I'm going to create a new node, a new pointer to a node called temp pointer. And, oops. And I'm making it point to the same thing that list is pointing at. Okay. And then I'm saying list gets list arrow next. So that means take this pointer here that's pointing at list and make it point at the same thing that list arrow next is pointing at. So that's this. Right, so this is gone now.
Okay, I'm not crazy, I hear that, right?
Someone's got their music going or something back there? No? No? Maybe it's coming from like next door or something. All right. And then delete temp pointer means this goes away, right? Okay? And I think that's that. So what I've done there is I have accomplished deleting the first node in the list. Right? Okay. There's actually one more little detail that we're missing from this case. Yeah. Found. Right? We have to set found to something. Right? Okay. That makes sense to everyone? Okay. Now I could have specified my delete function so that it didn't have a found parameter, and it just if it wasn't there, it didn't delete anything, and it didn't tell the caller that. But I chose to put that in there. Okay. Yeah.
Why isn't that the return value?
Did we have this question last time?
We met it for the insert.
Okay.
Which, you said it potentially need to return the record, because the record may have more information.
I think it was the find. Oh, the find.
It was fine.
Right. Okay. So why don't we just return? Oh, why don't we just make that a return? I think it's when you call this in the client program. If the return value was delete, Boolean, then instead of saying list.delete, you'd have to say something like found gets list.delete, and a lot of that might be okay. It would violate one of our style conventions, which is that let me see how I put it. Maybe not. If you have a function that accomplishes something like deleting a node from a list, then it should be a void function. Because if I said something like found gets this.delete num, okay, this when you look at something like this, and now what I'm doing here is I'm making an argument for my viewpoint. Okay, this is not necessarily like a right or wrong thing. Okay, but in my view, when you use an expression like that on the right side of an assignment operator, what should be happening is it should be calculating some or determining some value and returning it. There shouldn't be some sort of a side effect going on, right? Because although it doesn't read like an algorithm that way, or anyway, that's the best I can do on it, I think. I think it works better to just say delete and then check the value of found after you've called delete. All right, so I guess I should test this and see if it deletes the first item in the list, right? I know, 2 5s. Okay, I don't need to find anything. So I'm going to try deleting the 2. Yay. Okay. All right, so let's see. We did the general case. We checked for the last, deleting the last item in the list. We checked for deleting the first item in the list. Any other boundary cases we should check? Yes. Delete something that's not even in the list.
Or that would be deleted everything.
You mean, I'm not sure what you mean. If I can't delete everything, you mean if I go through and delete everything one at a time?
Yeah.
So 4, 9, 7, 8, 5. Okay, the list is now empty. So I guess the next question would be, what happens if I try to delete something when the list is empty? So that's similar to what the other suggestion was, right? Trying to delete something that's not there.
Yeah.
Okay. So in this case, if I try it, it just says 5 is not in the list. That's a good sign, right? Let's start it over again. And make a list. And then I'll delete the number 24. Oh. Delete the number 24. And that just tells me it's not on the list. Okay? That's definitely correct, though. We needed to check that and make sure, right? And in fact, not only do I want to just run it and see if it works, I really want to take a look and convince myself that it does handle that case. So I'm going to look at my code here. Wow, that got kind of long, didn't it? So if I'm trying to delete something that doesn't exist, what's going to happen? I'm going to, and assuming the list isn't null, I'm going to get down here. I'm going to go through this while loop. I'm going to go all the way through this while loop until cur pointer is equal to null, right? And then I'm going to say if cur pointer is not equal to null, well, it is. So I'm just going to say found gets false, and that's it. Which is what I want, right? Okay. And if I'm actually having a null, so that's one boundary case, right? Then another boundary case is I'm trying to delete something from a null list. That's slightly different, right? Or it could be anyway. So if the list is null, I get here. If list not equal to null, it doesn't do that. Come down here. It's going to say cur pointer gets null, prev pointer gets null. While cur pointer not equal to null, it already is null. So I'm going to come down here, and it's going to say found gets false. So I think I'm good. Okay? So lots of boundary cases there, right? That's a big deal when you're working with linked lists. Okay? So we had the general case. We had first item, last item. And then we had item doesn't exist. And then we had null list, empty list. Okay, so we had 5 different cases we had to just check. Okay. Any questions about delete? Okay. Kind of feels like we're slogging through these, doesn't it? What have we've done like, so far we've done insert and find and delete, and it's taken us about 1 class period for each one. Okay, so I'm gonna go ahead and stop there so we can go over to the lab. And then next Monday I will definitely dive right into some of the stuff from the text I was going to talk about. But let me just say one more thing, and that is that I don't know how many of you are actually doing the reading in the text. but I honestly think that it will save you time in the long run if you just take some time and do that. It probably feels like I have too much to do already. I can't possibly take the time to read the text. But it could be the other way around. It could be that you can't possibly take the time to not read the text. So give it a shot. I mean, just set aside, say, okay, I'm going to take 2 hours and I'm going to see what I can get through in the text, and go ahead and do that. The one thing in the text I would say that you can probably sort of skim over at this point is in chapter 1, there's the analysis of algorithms stuff. We'll be talking about that later, but not yet. And then, like I said before, chapter 5 is kind of dicey because there's a lot in there that only comes up because he's creating this node class, so the linked list toolkit, I think he calls it. So in chapter 5, try to take a look at the algorithms in there that he's doing for inserting and deleting and stuff like that. Don't pay too much attention to all the other stuff going on. I know that's kind of messy, but that's the best I can do. All right, see you in the lab.